Hello everyone, hope you're doing well today. Today we are delving into chapter 6 and we're looking at the biomechanical foundations of human movement, and that's through the lens of kinesiology. So this field combines anatomy, physiology, and mechanics to help individuals move more safely, effectively, and efficiently. Here we go. So in this chapter, you should be able to define the term biomechanics and be able to articulate how it is related to kinesiology. You should also be able to identify the value of biomechanics in terms of physical education, exercise science, and sport, and understand some of the terminology related with biomechanics, and be able to describe selected mechanical principles and concepts and be able to illustrate their application and concepts to human movement and sport, and also be able to describe some of the techniques and technologies used to analyze motion. Kinesiology is a scientific study of human movement. It allows us to better understand how the body works during activity. The goal is to optimize movement, to prevent injury, and improve performance, as well as promote health. So what is biomechanics? Biomechanics applies mechanical principles to understand the actions of the human body and sport implements. It's a key component of kinesiology that helps us break down and improve every movement. Here we see students analyzing gait patterns. Observing these mechanics in real time helps connect theory to practice and allows us to understand stride lengths, step width, and movement efficiency. The scope of biomechanics is vast. It intersects with biology, engineering, robotics, physical therapy, prosthetics, and even military science. Its applications go far beyond sport. Studying biomechanics improves our understanding of both internal and external forces affecting the body. With this knowledge, we can enhance movement skills and design effective training programs. There are several specialization areas. Developmental biomechanics focuses on how movement patterns change throughout life, whereas the biomechanics of exercise ensures exercises are done safely and effectively. Oftentimes, that's a personal trainer or strength and conditioning coach that are looking at the biomechanics of exercise. Clinical biomechanics aids in injury prevention and rehabilitation for those of you who want to go on to be physical therapists or occupational therapists. You'll be using more of clinical biomechanics. Equipment design looks at improving tools like racing wheelchairs to optimize performance. Let's take a look at the major areas of study in biomechanics. These areas help us understand both the structure and function of human movement. We begin with the biological aspects, which focus on the anatomy and physiology that support movement, things like bones, muscles, and joints. And next we apply mechanics. These are the principles of physics to understand how forces affect motion in the human body. Within mechanics, we break things down further into statics and dynamics. Now, statics deal with systems that are not moving, much like what you see here in the squat, and that he is stationary, he is static. Now, of course, we add movement to that. It helps us understand posture and balance and how the body maintains stability during stillness or support. Dynamics, on the other hand, studies the systems in motion. This includes walking, jumping, running, anytime the body is in action. Now, under dynamics, we also study two subfields. There's kinematics and kinetics. Kinematics answers questions like how something moves. It focuses on factors like time, speed, velocity, and acceleration, while kinetics explores why something moves. It looks at the forces that cause movement, such as gravity, friction, and the action of muscles. Together, these areas give us a complete picture of how movement happens and how we can improve it. Biomechanics isn't just about movement, it's about asking the right questions to solve real-world problems. One example is, how do running motions change as children grow? This helps us adapt training and prevent injury across age groups. We also ask, how do forces combine to create maximum power and something like the tennis serve or in badminton serve? This kind of analysis can improve performance at elite levels. Another critical area is injury prevention. For instance, how can athletic shoes be designed to reduce injuries on artificial turf? Biomechanical research can lead to better materials and design that protect athletes. And finally, technique matters. We might study the best body position for swimming, for the butterfly stroke, to reduce drag and improve efficiency. Each of these questions drives innovation in sports science, therapy, and product design, as well as improving movement for people of all ages and abilities. Now let's review some foundational biomechanical terms. Velocity is not just speed, it includes both velocity and the direction the body is moving, while acceleration refers to how quickly velocity changes. If an athlete speeds up or slows down, they're experiencing acceleration. Angular velocity describes how fast something is rotating, like a gymnast spinning in the air. And angular acceleration is the rate at which that spinning changes, either speeding up or slowing down around an axis. Now, mass is the amount of matter in an object, and it plays a key role in how much force is needed to move it. While force is any action that changes motion, it could start, stop, or change its direction. And finally, pressure is the amount of force distributed over a specific area. This is especially important in contact sports and in footwear design. These terms are critical for understanding motion and improving performance or reducing injury risk. Gravity is the natural force that pulls everything toward the center of the earth. It's always acting on our bodies and must be considered in every movement. Closely related is the center of gravity, which is the point in the body where mass is balanced. Understanding this helps in improving balance and stability, especially in sports and rehabilitation. Now, friction is the resistance that occurs when two surfaces come into contact and slide past each other. Think about the difference between running on grass versus a gym floor. It's friction that makes the difference noticeable. Finally, work is defined as work applied to an object over a distance and in the same direction as that force. It helps us measure how much energy is used to move something. These principles are foundational to analyzing and enhancing performance from daily activities to elite level athletics. To wrap up our key biomechanical terms, let's look at power, energy, and torque. All are crucial to understanding high performance movement. Power is the amount of work done in a given time. It's not just about strength. It's about how quickly that strength is used. In sports like sprinting or Olympic lifting, power is the game changer. And so oftentimes we'll utilize jump training to help improve our vertical jump. You'll also use a lot of other techniques as well with plyometrics to help increase power. Energy is the body's capacity to do work, and it comes in two forms. There's kinetic energy, which is the energy of motion, like a running athlete, and potential energy, which is stored energy. It's like a stretched muscle that's ready to contract. In fact, what we do is when you're getting ready to do a vertical jump, you'll do a counter measurement. You'll lower your body center of gravity in order to utilize that stored energy. And finally, torque is a turning or rotational force. It's what allows us to twist, pivot, or rotate, essential in movements like throwing, kicking, or even rotating the spine or bicycling, as you can see. These final concepts help explain how the body generates and controls motion, which is critical in sport, therapy, and daily functioning. As we wrap up, let's highlight a few key takeaways from today's presentation. First, remember that kinesiology is all about the scientific study of human movement. It brings together anatomy, physiology, and mechanics to help people move more efficiently and safely. Biomechanics, as part of kinesiology, applies the laws of physics, especially biomechanics to better understand and enhance human movement. Whether we're analyzing a jump, improving running technique, or refining equipment design, biomechanics is at the core. We've also explored several specialization areas such as developmental biomechanics, which looks at how movement evolves across the lifespan, and clinical biomechanics, which focuses on injury prevention with athletic training and rehabilitation. We also touched on fundamental concepts like kinematics and kinetics that deal with motion and the forces that cause it, as well as key terms like torque, power, and energy. Lastly, we discussed how biomechanical research drives improvements in sports, rehabilitation, and even technology as robotics and prosthetics. That is all that I have for you today. We will be going further into Chapter 6 and Part 2. I look forward to talking with you again. Have a great day.